I'm Farnaz Jahanbakhsh from MIT, and I'll be presenting this work that I did with my collaborators Amy Zhang, Adam Berinsky, Gordon Pennycook, David Rand, and David Karger. This work addresses the misinformation problem on social media. While a lot of the work in this area investigates approaches to find and label misinformation after it has spread, we think at that stage it's already too late. So in this work, we try to prevent misinformation from getting shared in the first place by getting users to reflect on the accuracy of the post that they're about to share. Let's review some of the approaches in this area. They include, for example, using machine learning models to detect false information, providing fact-checking information, and so on. Social media platforms have also reported working with moderators and third-party fact-checkers to find and remove misinformation after it's been published. And these are all valuable, but they don't confront the underlying reason why misinformation spreads so easily on social media. And that, we believe, has to do with how social media prioritizes engagement over accuracy. For example, a user who comments on a post to refute it may unknowingly be spreading the post more because the system considers the interaction as engagement. Also, part of why users post on social media is to receive social feedback, and there isn't much attention given to the accuracy of the post. Another problem with some of these approaches, like providing fact-checking information about a piece of content that has already spread, is that they just can't keep up with the misinformation, both time-wise and with respect to how much the correcting information is shared and how much visibility it gets. Yet another problem is that fact-checking provided by the platforms forces them into a truth arbitration role, and with that we'll be giving them perhaps more power than we should. So the motivation for work was to think about how we can alter social media platforms to curb misinformation at the time of sharing content, not after the fact. The design changes that we suggest do raise a small barrier to sharing, but they result in sharing more accurate content compared to inaccurate. And they're lightweight. The amount of effort that they require is kind of similar to how users currently react to posts on social media or comment, so they can scale. The design changes that we had in mind were, first, requiring users to click a button saying whether the content that they're about to share is accurate or inaccurate. Second, requiring users to choose at least one reason from a checklist of reasons, indicating why they think that the story that they're about to share is accurate or inaccurate before sharing it. And third, requiring users to write a short explanation of why they think that the post they're about to share is accurate and inaccurate. And so the idea is to shift users' attention away from mere social feedback to accuracy. In fact, prior work has shown that priming users to have accuracy on top of their mind when they're considering sharing a post can help reduce their likelihood of sharing falsehoods. But there has been little work on how accuracy nudges could be integrated into platforms in a lightweight manner. Requiring users to assess accuracy before sharing, if it works to reduce the sharing of false content, can prevent the spread of misinformation at the source, rather than correct the misinformation once it is already spread. Another advantage would be that users on social media would then get friend source assessments, rather than assessments imposed on them by the platforms. So one of the approaches we had in mind was for users to choose a rationale for why the post that they're about to share is accurate or inaccurate from a prepared checklist of reasons. Why did we want to introduce such a design change? Well, first, we expected that getting users to choose a rationale from a checklist would help guide their reflection on the accuracy of the content along the various criteria for accuracy. And second, then the reasons could be captured as structured metadata by the platforms and shown to other users who could then evaluate the assessor's reasons for themselves or use the reasons for filtering posts. Now, our first problem was, where do we get those reasons? Which brings us to our first research question. What are the reasons why people believe or disbelieve news claims? And our second research question was, how does asking people to provide accuracy assessments of news claims and their rationales affect their self-reported sharing intentions on social media? The answer to the first question would be a taxonomy of reasons that we could then use to answer the second question. So we designed 2 studies to answer these questions, and we conducted both on Mechanical Turk. In the first study, which is aimed at understanding people's reasons for believing or disbelieving news claims, we had a set of participants work through an online survey, which showed them a series of 10 claims one at a time. The claims varied along different dimensions of veracity, topic, partisanship, and they came from various sources, some mainstream and some conspiracy websites. For each individual, the 10 claims are randomly chosen from a larger pool of claims. We asked the following 2 questions for each one. Is the claim accurate or inaccurate, and how confident are you in your belief? And then we followed up by asking why they believed the claim was or was not accurate. So now we had free text responses of people explaining their rationales. This was only the first stage of the study. In this stage, we built a preliminary taxonomy of reasons why people believe or disbelieve news claims. But the whole purpose of this study was to build a taxonomy that untrained people could use to check off the reasons. We wanted the labels that we had designed to be in alignment with what participants perceived them to mean. So here comes the next stage. In this stage, we performed another round of the study. Only this time, we presented our taxonomy in the form of a checklist and asked people to check the reasons and also provide free text elaboration. Then we coded their free text responses and compared them to the labels that participants themselves had given to their answers. We measured the agreement score this way and revised the taxonomy accordingly. We performed 3 iterations of the status study, revising the taxonomy after each iteration until we obtained an acceptable agreement score between the labels that participants checked off for the responses and the labels that we assigned to the responses. Now I'll be giving you a brief overview of the taxonomy that we developed. There were some categories emerging from the study that would definitively, from the evaluator's perspective, determine that a claim is true or false. We wanted to signal the strength of these categories, so we grouped them under the name accurate on the evidence for reasons arguing that a claim is accurate, and inaccurate by contrary knowledge for reasons refuting a claim. For instance, one of the categories that we placed under accurate on the evidence was the following: I have first-hand knowledge of the subject, or I'm an eyewitness. This was also a category that was conversely used to refute claims. There were some rationales that were not conclusive, but rendered a claim plausible or implausible. An example of a rationale which makes a claim plausible is the claim is consistent with my past experience and observations. Conversely, an example of a rationale that makes a claim implausible is, if this were true, I would have heard about it. And finally, some rationales were even weaker, were rather speculations, and we grouped those under the term don't know to signal the lack of strength. There were other signals of credibility that emerged from participants' responses that didn't necessarily confirm or refute a claim. We separated those into another dimension. One such signal was the claim is misleading. A claim could be misleading and true or misleading and false. So now that we had a checklist of reasons why people believe or disbelieve news claims, we could test the effects of our proposed interventions. For that, we did another study. In this study, another set of participants were shown a series of 10 claims one at a time through an online survey. Each participant was assigned to one of the 4 experimental conditions. If they were in the control condition, after seeing each claim, they were only asked if they would share it on social media and then a follow-up why or why not question. If they were in the second group, which was one of the treatment conditions, the survey would first ask them whether the claim is accurate or inaccurate and how confident they are in their belief before asking them whether they would share it on social media. In the third group, in addition to asking participants whether the claim was accurate, the survey required them to provide the rationale in free text, and in the fourth group, the survey asked them to check the rationale from a checklist of reasons, which was the taxonomy that we developed earlier, in addition to explaining the reasons in free text. This study gave us over 21,000 data points. I'll be sharing the high-level results with you, and for the details, I invite you to read the paper for yourselves. So we wanted to know what effect each of the experimental factors has on people's self-reported sharing behavior. And as a reminder, the factors were asking about accuracy alone, asking about reasoning in free text on top of that, and additionally asking users to select the reasons from the checklist that we had provided. We also investigated the effect of veracity, which is the objective truth of whether a claim is or is not true. We found that veracity does indeed have a significant effect. Accurate headlines were assured more than inaccurate headlines, and that is good news. We found that providing accuracy assessments about an article before deciding whether to share it lowers the probability that one shares the article for both true and false headlines. However, this intervention resulted in a higher decrease in sharing of false headlines compared to true. So overall, the ratio of shared false headlines to true ones was decreased. Similar to the results observed for requesting accuracy assessments, we saw that requesting reasoning reduces sharing of all headlines, but false headlines to a greater degree in comparison with condition 2. So the ratio of false shared headlines to shared true headlines is reduced. We found that additionally, requesting users to check their reasons for why they believe the claim was accurate or inaccurate decreased sharing of both false and true headlines to the same extent. Although this observation may seem to suggest that selecting from a checklist of rationales in addition to providing accuracy assessments and free text reasoning doesn't seem to help in further differentiating between false and true content, we believe that such a checklist can still be used on the platforms for the added benefit of capturing and surfacing reasons in structured form. Now I'd like to wrap up with a few points. We saw that the interventions result in the reduction in sharing of false content, but also of true content to a lesser degree. The effect of the reduction of false content will be exponential when we consider a chain of users who will each refrain from sharing a fraction of the inaccuracies that appear on their feeds. So the effect will end up being large. Another point is that if the accuracy assessments and reasons are captured in structured form as part of the metadata on the platforms, then they can be signaled and can even be used to filter based on. For example, A user may choose to see only those news stories that have been evaluated as true by a set of their friends because they have domain knowledge on the topic.